Hi, my name is Kaibun Yi. I'm from the Electrical Engineering Department and currently participating in a summer undergraduate research experience program. During this summer, I've been doing this project named Electronic Detection of Specific Protein Binding using carbon nanotube field effect transistor, or in short, we call it FET. So these are the three things that I'm going to present today. Firstly, I will talk about what's that carbon nanotubes. Then I will introduce my research and some of my motivation of the research. And lastly, I will end my presentation with my summer undergraduate research experience. So what's that carbon nanotube? Carbon nanotube is actually a sheet of graphite, which commonly we call it carbon, which has been rolled up into a cylindrical shape. It has a typical length of about a few microns and diameter of about a nanometer. What makes it really special is that it's small, stiff, and it displays really good electrical properties. It's extremely good conductor or semiconductor. Moving on to my motivation of my research, knowing that current biological sensing techniques commonly rely on optical detection principles, which are inherently complex, as they require multiple steps, complex data analysis, relatively large sample size, and time-consuming. We understand that these techniques are highly specific or sensitive, but it's more difficult to miniaturize it. Hence, we came out with these electronic detection techniques, such as field effect transistor, fabricated using carbon nanotubes, as an alternative for this solution. With the advantage of all the carbon atoms being laid on the surface of the carbon nanotube has become a potential candidate to probe the biomolecular world. Now, I will have a short introduction to my research. So basically, during this summer, I'm dealing with functionalizing carbon nanotubes to make them biocompatible. We do it by immobilize the biotin, is one of the biomolecules, onto the carbon nanotube, as you can see from the picture, the figure besides, to anchor its bioreceptor molecules, which is streptavidin. For your information, biotin and streptavidin naturally binding or coupling together, and then we examine the change in device characteristics of the carbon nanotube. We think that the mechanism responsible to the change of device characteristics is believed to be the charge transfer between the analytes and carbon nanotube. Hence, for the changes in device characteristic, we can infer that there's some kind of specific protein binding to the carbon nanotube. Lastly, I'll talk about my summer research experience. Throughout the summer, I've been learning many things. The first thing is that I have did some literature viewing. In the beginning of the research, it's always important to read some research paper or thesis. And also, I learned doing some measurements using a probe station. I learned analyzing experiment data. And also, I attend meetings weekly and some enriching seminar offered by College of Engineering monthly. Lastly, and last but not least, I learned to utilize some of the state-of-the-art nanofabrication facilities in U of N Solid State's electronic laboratory. This is one of the places which I worked during the summer. For the figure, you can see that this building called Engineering Research Building. The figure on your right side is a probe station where I did some device testing. The device is being the chips that you can see on the bottom left side. Also, I work in Lurie nanofabrication facilities, or usually people call it clean room. From the bottom left pictures, is the gowning room. This is the place where we dress ourselves with the bunny suit to go into the clean room to prevent bringing some dust into the clean room. And the picture on the bottom right side, you can see the whole room is in yellow color. The reason is being that there's no UV light in the clean room, and That's why it's yellowish in color, the whole room. This is to prevent the UV light from destroying your device. Wrapping up my presentation, I think that SURE program has been a really rewarding experience for me. I learned more about research, and what's more, the take-home message from my research, summer research is that I realized that carbon nanotube FET is really a promising candidate for electronic detection of biomolecules. With that, I end my presentation. Thank you.